I'm Sabrina Ramonov, and in this video, I'm going to give you a sneak peek of a mini LLM game I'm building called Llama versus Lava. And it's basically the continuation of my previous video on LLM agents pathfinding, which I'll pull up here. You can tell I completely reskinned the game. I thought it'd be more fun with an actual theme. So in my previous video around using LLMs for AI agent pathfinding, kind of had this little bear walking around what looks like a cavern, reskinned everything. So I replaced this with a llama, and I'm going to add animations to the llama. And the places where the llama can't move are these like orange lava tiles. And that's why it's called Llama versus Lava. And the purpose of this game, or like the cool aspect of this game, is the whole goal is you need to write a prompt that enables the llama to pathfind or like figure out its way through this maze without falling into lava. And basically your score is how many streaks the llama can move without falling into lava. And so it's actually much harder than it seems. So here, this is the default prompt that the game starts with. You're given a 3x3 matrix where each value is 0 or 1. Use zero-based indexing. Find the row and column containing the value 1. And here's the grid, and only output the row and column. Now, I'll explain in detail like what that means if you haven't watched the previous video. But first, let me just run it so you can see how the game works. All right, so when I press run, the game is actually going to take my prompt and use that to power the llama's pathfinding. So it's running. Oh, the llama moved. Yay. Sometimes like you lose even on the first move. So, and here's a summary of what happened. Basically, the llama fell into lava after 2 steps. And this is an explanation of exactly, their last step. The llama moved to an invalid diagonal position, 0, 0. And here's the prompt output that caused the failure. So here the LLM is thinking, it examines the grid, it finds multiple coordinates that are valid, meaning they correspond to the value 1, and then these are the coordinates where the value. Yeah, unfortunately, so the way kind of the code base works is it looks for the first valid row column coordinate. In this case, it's 0, 0. But that's actually an invalid move. So just like in a 2D platformer, you can't just move diagonally. You need to move up, down, left, or right. So let me explain in more detail what that means, especially if you haven't watched my previous video on AI agent pathfinding. So here's the code base I use for testing pathfinding. And the way to think about it is the llama has kind of short-sighted vision around it. It can only see kind of one square around it. So the llama starts here in the center of the grid. And this is a 3x3 kind of matrix. So it uses zero-based indexing from the top left corner. So let's say the llama wants to move to the left. That would be x equals 1, y equals 0. That would be the move. And because the llama is in the middle, it can't move diagonally, right? Just like in a 2D kind of pixel game, and you move up, down, left, or right. So the only valid positions it can actually move are here, 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 and here. Okay, so there's only 4 valid positions, and there's actually 5 invalid positions. So here, it's the llama is not allowed to stay in place. Otherwise, you can have an infinite winning streak just by having the llama never move. And so this is an invalid position, and then the diagonals are invalid. So like 0, 0 is invalid here. 0, 2 is invalid. 2, 2 is invalid. 2, 0 is invalid. Okay, so that's just a quick explanation of what's happening in the game. So how that maps back to the llama is, again, the llama is currently at 0, 0. In this case, since there's lava on the left and right, it can only move up or down. So that would be kind of the valid answer in this case, because it can't move diagonally, it can't stay in the same spot, and it can't move left or right because there's lava there. And in my previous video on pathfinding, I basically iterate on the pathfinding prompt directly in the code base. So this will look familiar if you watch the previous video. This is basically the prompt I'm using, for example, to test naive pathfinding, and I continually iterate on this prompt to achieve higher and higher accuracy. So what I'm going to do right now is actually start with this prompt. I'm going to copy paste it into our game and then see how that goes. Only thing is I do want to keep the grid. Here, I do want to keep the grid. I don't think I need this since the prompt already says give me an answer exactly like this. Okay, so what we're doing is taking the best performing prompts from my previous experiments on pathfinding, pasting it in here and seeing how it does. Now, I don't expect it to perform like spectacularly because in the previous video and experiments, this was a pretty like kind of naive setup. Basically, in the grid or 3x3 matrix, only one value was flipped to a 1, meaning there was only one possible choice where the llama could move, which is a constraint that makes everything easier. It simplifies it. Basically, the llama just needs to look for the single one value in this entire matrix. Now, what we have in this version of the game is a bit more advanced. There's actually multiple options where the llama can move. There's multiple ones, like here on these diagonals and stuff, but it can't move diagonally. So it's a bit noisier, which makes it harder. And that's why I don't expect our prompt from the previous experiment to perform like 99% like it did in the previous experiment. But let's go ahead and run it anyway and see what we get. Ooh, so the llama died after one step. The llama did not move at all and was engulfed by lava. Okay, that makes sense. So the prompt output was 1, 1. And again, just imagine kind of a 3x3 grid where the llama is 1, 1 corresponds to the center of that matrix. And so that means the llama didn't move at all. So the first thing I want to try is updating this prompt to clarify that there are multiple entries that could contain a 1. Because right now, the way the prompt is worded, it sounds like there's only one entry that could contain a 1. So find the row column entries containing 1. And give me answer. Okay. Expanding this box. Let me try like remove answers from the list. Move. They are not in. Let's see how that does. Okay, that didn't do well either. But let's see the prompt output. So it says, first create a list of all the entries containing 1 in the 3x3 matrix. I don't think all those entries were containing 1. Okay. The list becomes 1, 1, 2, 1, 1, 2. I'm going to copy paste that so we can see. No. 1, 1 is the center, so that's not good. 2, 1 is here, so that's good. Okay, and then 1, 2 is lava, so that's not good. So there was one right answer, but it keeps interpreting 1, 1 as a valid value, even though I said remove entries from the list if they're not one of the following, and 1, 1 is not one of the following. So I'm gonna try updating this. Maybe entries is weird. Let's say coordinates. Remove one of the following coordinates delimited by triple back quotes. Like, I like the format of the output. It's nice and clean. The problem is just that 1, 1 keeps popping up as an answer. Maybe I'll have another check. This is not like super inefficient, but your answer should never contain 1, 1. I'm just curious if that removes it, and if that removes it, could I write the diagonal entries as well and hope it removes those as well. All right, let's try running this. Ugh. Remove the coordinates. So the final answer is 0, 0. That's a diagonal. 0, 1. The good news is, well, it already didn't have 1-1 at this step, so it's unclear um, whether it helped. It was, but yeah, let's try adding the diagonals and see if that works any better. So 0, 0, 0 is the upper left corner, and then we want 0, 2 is the upper right corner, and then 2, 0 is the bottom left corner, and then 2, 2 is the bottom right corner. And one of my motivations for building this is it's just a more fun, interactive way to iterate on the prompt than what I was doing previously in the previous video. So again, in the previous video, I was like literally, opening one of these files and then rewriting the prompt here. And then I'd run tests down here in my terminal, set the number of samples we want in the test set, and then I'd look at the log output that was created from the test run. And then sometimes I'd actually run it in the game to visualize like the answer that I was getting and like how effective it was. But this is kind of more fun because it gamifies the entire process. Now I really want to help this llama survive and navigate through this like treacherous lava-filled maze. And so it's just a little bit more fun. Obviously, there's some UX improvements I want to make before I actually release this, and that's why I'm calling this kind of a sneak peek. For example, it's like really annoying that I have to like scroll like this. I also don't like that once I close this, then I don't know like exactly what I got wrong, so it makes it hard to iterate on the prompt sometimes. But really much more fun than like just doing it purely in the code base. Okay, unfortunately, our llama died after one step, but let's see what the final answer is. Oh. Well, it kind of just spit out the allowed coordinates, which I'm not sure. It would be nice if I included a picture of the grid or something, because like now I'm not sure, are these the allowed coordinates? I have to like close this and check. One problem though is like in my code base, my parser looks at the output and grabs like the first coordinate it sees and assumes that's the answer. So like at this step, when the LLM makes a list of row column coordinates containing 1, and then it lists like a bunch of coordinates, my parser is actually pulling this 0, 0 as the very first answer, which is not the answer the LLM intends. And so that's why it's marking it as false. It's like at least 0, 1 here is a valid answer, but again, my parser is interpreting 0, 0s as the LLM's answer, which is an invalid diagonal position. Again, 0, 0 corresponds to the upper left corner. So I think what we need to do, I do want it to remove the coordinates and stuff, but I don't want it to output all this other junk because that confuses our parser and stuff. So let me close this. Do not give an answer until I tell you to. Let's see. Please let me know when you're... I said give me an answer at the end. Okay. How about if I just change the word to provide so it matches what I said earlier? Okay, I mean, now it doesn't have all that junk. Let's see. 0, 2 is still a diagonal. So it didn't... Oh, hang on. The initial list of coordinates containing 1 is this. Please let me know when to proceed with the next step. Okay. So yeah, unfortunately, it just got kind of stuck at this step here. Make a list of row column coordinates containing 1. So maybe I don't say make a list because that sounds like I'm asking for an answer. Let's say find the row column coordinates containing 1. I don't know if the removed worked better or your answer worked better. But what I want to do is move this afterwards. Ugh, yeah, if I don't remove it here. be nice to like comment things out so I don't have to retype it or whatever. Yeah, unfortunately, it's just given me these diagonals again. And the thing is, the diagonals, like looking here at the llama, the diagonal is a value 1, but it's just an invalid move. And so it is interpreting that, it is a safe spot to move. There's no lava there, but it can't actually move diagonally. And so what I've been trying to do, or my approach thus far, has been to like get the LLM to first analyze the matrix, figure out all the ones, and then remove the coordinates where it can't move. But that doesn't seem to be working very well, and so I'm thinking of switching it up. So here I have updated the prompt specifying that the LLM is starting at the center of the 3x3 grid, and that it can only move to these 4 coordinates, but they have to contain a 1. And it tends to stay in the same spot a lot. So I'm trying to specify like it cannot move to 1, 1, which is staying in the same spot. Like that's not a valid move. Then I ask, where do you move? And provide an answer exactly like this. Come on, llama. Okay, we got kind of lucky there because there were a lot of options. So even though, the llama died after 3 steps, I don't know if I believe that this was particularly effective because there were a lot of valid options it could move to. Let me try running it again. That's interesting. It keeps outputting 0, 1. Let's try, you can move down, left, or right. You cannot move diagonally. I don't know if this is helping, like telling the LLM that it's at the center. You must move to a grid containing 1. Okay. Come on, llama. Oh. Well, it's nice that it at least inputted the grid. Yeah, there was only 1 valid move, if I remember correctly. It would have to move down. So here it moved up. And I'm wondering if it's moving up because I list it here first. Like you can move up, down, left, or right. And I think it's just waiting it. Like it might be waiting it because it comes first. You must move so you cannot move diagonally. So I'm trying to remove this so that it doesn't overly weight moving up. Nope. So you are given a... Yeah, let's try something else. Let's switch it up. So you are given a 3x3. I'm going to rename this to matrix. So it's not super confused. Grid is a variable name, so I'll keep that. Given a matrix. Then let's say check the values at each of these coordinates and return the first coordinate that contains 1. And the list of coordinates. Let's just make it super clear, delimited by. And then we list the coordinates again. 0, 1. That's up, and then this is left, and then I want right, and then I want down to, oops, this should be 1. Okay, let's try that. All right, 4 steps. That's better than 1 or 2. First coordinate that contains 1 is 1, 0, which is false. Yeah, I don't know if it's actually checking the value. I think it's just reading um, like reading the list of coordinates rather than checking the values. Okay. So it might be my wording here that's confusing it. It's not quite checking and then returning. Okay, here that's better. And I think all I did is I replaced coordinate with matrix entries. So 0, 1. Okay, here at least it's checking what the values are. But it's really weird because here the first coordinate that contains 1 is 0, 1. And then later it says the first coordinate that contains 1 is 1, 0. Um, yeah, the problem is if it gives you a breakdown like this, again, our parser is going to look for the first coordinate. So it's going to look for that 0, 1. So I actually like this answer. And maybe we should format it this way. So I'll ask the LLM to format it like this. Yes. The first. Yeah, I'm using different terminology there. Okay. Yeah, it's so weird. The first entry that contains 1 is 0, 2, and that's an invalid diagonal. But then it says here the first entry that contains 1 is 1, 2, which is correct. Here I change things up a bit where I specify what the allowed coordinates are. Again, they're up, down, left, or right. And then I ask the LLM to find the row and column containing 1 within those 4 allowed coordinates. And so let's see how it does. Is it moving? Oh man, I hit the API limit request. Well, anyway, so that concludes kind of my sneak peek preview into Llama versus Lava. And honestly, it's pretty fun iterating on the prompt here and just visualizing it. Obviously, like I mentioned, there's a bunch of UX improvements I want to make. Like this text box is kind of limiting and annoying. I want to be able to see like what the matrix was in addition to the prompt output, things like that. But yeah, drop a comment below if this is something you'd be interested in trying out. It's just going to be kind of a mini game that I release in my journey to build a multi-agent simulation. So thanks for watching. I'm Sabrina Ramonov. Until next time.